Hello, and today we're going to look at solving systems of equations. This is a video about 3 ways to solve systems of equations. We're going to just do one of each, and of course you'll have some worksheets to work through, and there's 3 different methods, and then we'll go into a couple more methods in the Algebra 2 review. But the first method of solving systems of equations is graphing. Now when you're graphing, you're going to graph 2 or more lines. You'll have one of 3 possible answers. 1, you're going to get an intersection. The intersection point works both it gives you a true statement in both equations. No intersection means you have parallel lines. Parallel lines mean that they do not intersect. And if you have an intersection, you have a solution. If you do not have an intersection, you have no solution. And then if you have the same line, you have infinite solutions, or all real numbers. So those are the 3 possibilities you're going to have. With graphing, you just graph both lines and see if they intersect. Now you can use your calculator with this, but this is not a calculator review. This is a algebra review, so we're going over how to do the algebra. So I'm going to take and draw an X and Y axis. Oops, that's wrong. Let's try that again. There. And I'm going to make up 2 equations. 2x plus 2y is equal to 4, and 2x plus 3y is equal to 6. Now the first thing I'm going to do is solve for y. You could use the intercept method. In fact, we'll use the intercept method, and I'm going to plug in 0 for x for my y-intercept. Oops. And 0 for y for my x-intercept. So 0 for x will give us 2 for y. 0 for y will give us 2 for x. Same thing over here. X-intercept, 0 for y, y-intercept, 0 for x. 0 for y gives us 3, 0 for x gives us 2. So I'm going to plot the first line. 0, 2 is your y-intercept. 2, 0 is your x-intercept. And we'll color that line. I'm just going to, oops, thought I had my straight line maker. And now we're going to do 3, 0, that's the x. 3, 0 is your x-intercept. Y-intercept is 0, 2. And of course, we all see that we see that the intersection, or the place where they intersect, is right there, which has a point of 0, 2. And that is the intersection of those two lines. Now, what does that mean? Well, this is X, and this is Y. So plug it in. So I'm just going to erase this right here and put a set of parentheses. And I'm going to erase this over here and put a set of parentheses. And I'm going to plug in 0 and 2. 0 here, 2 here, 0 here, and 2 there. And do the math. I'll do it in blue. 0 times anything goes out, and that's going to leave 4 is equal to 4, which is a true statement. 0 goes out here, and this leaves 6 is equal to 6, which is a true statement. So the intersection point represents the number, or the coordinate, the X and Y pair that works in both equations. Now, you would have got the same answer if you would have used method 1, method 2, or method 3, but you would have to solve for Y on both instances. So always remember this too. Now, I will say one more thing. We talked about this earlier with the solutions to an equation. And I'll put this in another color, maybe magenta. Remember when I told you that you have an untrue statement, which is called a contradiction? When you're doing the next couple of methods, you may not get, you don't graph the lines, okay? So you just do algebra, and you will get a contradiction with the untrue statement, and that would be no solution. Here, you would get the identity, which is a true statement. So true gives you all real numbers. Not true, like 4 is equal to 8. Not true is a contradiction and gives you no solution. And we talked about that when we solved equations. And I think we did one, and it came out to be 4 is equal to 8 or something like that. And that's no solution. So that's your first method of solving systems of equations, graphing. Your second method, and we'll do the same one, we'll do 2x plus 2y is equal to 4 and 2x plus 3y is equal to 6. So I'm going to 2x plus 3y is equal to 6, and 2x plus 2y is equal to 4. I think that's what we did. Now, this is called, the second method is called substitution. Substitution is where you solve one for y or x, solve for y, x, or y, and plug into the other. We talked a little bit about this with composition. Composition is a form of substitution. Now, it don't matter which one you solve for. You got 4 you can solve for. You can solve for this x, you can solve for this y, you can solve for this x, or you can solve for this y. I don't care, and you will get the same answer no matter which one you solve for. So I'm just going to pick that y right here. I'm going to solve for this one. So I'm going to come down here and I'm going to say 2x plus 2y is equal to 4. I'm going to take this across the river, and that gives me 2y is equal to negative 2x plus 4. Divide by 2, divide by 2, divide by 2. Y is equal to negative x plus 2. So now I've got one of my y's, and I'm going to highlight that. One of my y's is equal to negative x plus 2. So I'm going to take that negative y, or I'm going to take that y, and I'm going to plug it. I'm going to plug it into the other equation for y. So I'm going to go over here, and I'm going to rewrite the equation. 2x plus 3 times big set of parentheses equals 6. And you notice that whenever I do plug in something, I use a big set of parentheses. No matter what I'm teaching, I do that. And I'm going to put yellow parentheses around this, because that means I'm plugging in that x, negative x plus 2. Negative x plus 2. And now I solve for x. 2x plus, well, that plus and that negative is going to turn into a negative. So minus 3x plus 6 is equal to 6. 2x minus 3x is what? Negative x plus 6 is equal to 6. I'm going to take this x across the river, and I'm going to bring this x back, and I get 0 is equal to x. Now I take that x, and I back substitute it into my y formula. And I go y is equal to negative parentheses plus 2, and negative 0 plus 2 is 2. So our two lines intersect at 0, comma 2, and that's what we found out in the first method of graphing, hold on a second, no. It crossed at 0, 2. So you can use the methods of solving systems of equations to check each other. And that's how you do the substitution method. And the last method is what we call elimination. Elimination, I like elimination because it's easier to me. Elimination. Now, when you use the elimination method, you're looking for three things. One, you look for opposite signs. Two, you look for same coefficients, or equal coefficients, same, whatever you want to call them, same numbers. And three, if not 1 or 2 and 2, do it. In other words, if you don't have number 1 or number 2, you're going to have to find a way to do it. So our first equation was 2x plus 2y is equal to 4. The second is 2x plus 3y is equal to 6. Now, I don't have opposite signs, but I do have same coefficients. I don't have opposite signs, so I need to make it opposite signs. So I'm going to multiply the bottom or the top, doesn't matter, times negative 1. Why? Because I want these 2's to be opposite signs. So I'm going to rewrite the top. 2x plus 2y is equal to 4. And negative 2x minus 3y minus 6. And what happens to the x terms? They eliminate. And that leaves me with negative y is equal to negative 2, and y is equal to 2. Because you divide by negative 1. Because you got to get the variable by itself. So now what do I do with that? Well, you take that 2 and you back substitute it into either one of these. I'm going to use this one. 2 times x plus 2 times y is equal to 4. And I'm going to plug that 2 in right here. 2x plus 4 is equal to 4. That's going to cancel with this one. 2x is equal to 0. X is equal to 0. So our two lines intersect at 0, 2. And that is the same as we got before. Now, all of these three methods that I just showed you should knock some cobwebs loose on how to solve systems of equations. And when we get to the Algebra 2 review, we will cover Cramer's rule as well as matrix.